So, hey students, we're going to be working on this how milkweed plants defend against monarch butterflies. And this is one of my favorite topics because I have tons of milkweed in my yard and I get lots of monarch butterflies every year. And in 2025, it's being debated to have them put on the endangered species list. So, if this is being seen in future years, that decision's already made. So, that's kind of cool too. But with monarchs, they are actually very, very picky eaters. They will only eat, their babies can only feed on a plant called milkweed, and milkweed isn't really that pretty. And so it's been pulled out of a lot of places here in California and across the United States and across the globe. And our Western monarchs here on the West Coast are really threatened, and their populations have been currently very unsteady and dwindling. But being such a picky eater makes it really difficult because if that's the only thing they can really eat, it makes it hard unless people plant a bunch of milkweed. So monarchs eat this food, but then milkweed doesn't want to get eaten by monarchs or anything else. And lots of other things like to eat milkweed too. And so milkweed has actually developed some ways to kind of fight back against monarchs and the other insects and animals that might eat it. So a couple of the ways that this happens is that the milkweed, so first the monarchs will come and lay their eggs on milkweed, but then pretty immediately after the eggs hatch, the babies come in contact with something called the trichomes, which are the tiny little hairs all over the milkweed. And there's a picture of that here on one species where it's very hairy. And the monarch caterpillar actually has to shave an area of the hair before it can start eating. It wants to eat just the leaves. But then as soon as it bites into the leaves, it also can get a very thick mouthful of white latex. So if you've ever raised milkweed, the milky white part that comes out is actually latex, and that is used to make like latex gloves, for example, balloons in some cases. And it's this very kind of sticky, expanding like white fluid that will come out, and that's going to jam up their mouths and make it hard to eat. And then additionally, milkweed plants actually have toxins in them called cardiac glycosides, which are poisonous to a lot of animals, and they're not even good for monarchs. But monarchs eating them will tend to keep those poisons in their body, those toxins in their body. And then as other things come and eat them, they don't taste as good. So some people call the monarchs poisonous, but lots of animals can eat monarchs, and maybe it's not good tasting, but they generally won't die. So this is from, I should have credited it in the beginning, but this is from Data Nuggets, and this is a scientist that they're featuring named Anurag Agarwal. And he basically talks about his love for plants in general and how he studied milkweed. And he was interested and wanted to see how the milkweed was like evolving defenses, and then the monarchs were going to try to evolve ways to get around those defenses. And that's called an arms race. When one group tries to develop new weapons and the other side tries to make weapons that overtake that, that's called an arms race. So basically, he wanted to know this, and I underlined it in pink because I think nearly this whole paragraph is pretty important in the reading. It says he wanted to know whether milkweed's defensive traits are still effective against monarchs, or have monarchs evolved ways to make their defenses unaffected. They're not even affected by the milkweed's defenses. So basically, who's ahead? Is the milkweed doing better, or are the monarchs able to overcome all of their defenses? So because each defense trait might be in a different phase of the coevolution process, maybe some would be effective defenses to herbivory, meaning being eaten, but others would not be effective. So he predicted that monarchs would be harmed by different things, the trichomes, which are the hairs, the latex, and then the cardiac glycosides. So he thought maybe some cause more harm to the monarchs than others. So to test this, he basically took 24 different North American species, and then he put a newly hatched, and you can see him with a paintbrush putting a newly hatched monarch caterpillar on it, and then he measured the growth of the baby to see how much it grew over 5 days. So what you guys are going to do is, even though there were 3 defenses talked about here, the trichomes, the latex, and the cardiac glycosides, we are going to skip the worrying about the trichomes because I didn't need you to do a 3rd data set. 2 data sets were enough for this. So we're going to be working on 2 data sets, which are the latex, and then now I'm just going to call it toxins, but if you want to call it by its real name, it should be cardiac glycosides. Okay, and with that, the first question is saying, to what extent do different herbivory defenses, like plant defenses, is what they mean here, to what extent do different plant defensive traits of milkweeds reduce the growth of monarch caterpillars? So that's the question. But I want you to put the question in your own words, like does eating latex affect the growth of monarchs? Does consuming the toxins in milkweed affect the growth of monarchs? Some kind of question like that. And then after that, I want you to write a hypothesis about that, okay? So the 2 things being studied here are the latex and the toxins. So just to be clear, in this top section, you should have 2 questions. So I'll write a 1 and a 2, just so you know. So you should have 2 questions written there. And then this part that says, what is a hypothesis? I want you to write your best guess. So you're going to be writing out a hypothesis here, and you can have a joint hypothesis about these 2, or you can have a separate hypothesis. So remember that I like your hypothesis written in an if-then statement. So you can say something like, if monarch caterpillars eat the latex and the toxin, then they will not grow as big. Okay, so you're basically making the hypothesis that the latex and the toxin are going to make the monarch not grow. Or you could say, if the monarch caterpillar eats the latex and the toxin, then it'll grow just as big as normal, right? You could have that. Like, they're not going to be affected by it. Or you could even have, like, separate this out into 2 different hypotheses. Something like, if they eat the latex, then they will not grow or grow the same. But if they eat the toxin, that will affect their growth and they'll be smaller or bigger, whatever. Okay, so these can either agree that it'll grow the caterpillar or get it smaller, or you can say, hey, I think the latex is going to have one effect, but the toxin's going to have a different effect. So you decide here if you're writing 1 or 2 hypotheses. Okay, then we go down to our independent variable. Independent variable, a lot of students get tripped up by that. My brain also gets tripped up on that sometimes. So instead of independent variable, I like to kind of write a little note to myself that says, what are we testing? What am I testing? And here I am testing like latex and toxins. So the independent variables are going to be latex and toxins for me. And then the dependent variable, like I don't like the name of that as much because I kind of forget what dependent variable is. And then, so I'm going to write what results, or what do I expect to have happen? How about that? What do I expect to happen? Okay, and here, if I'm saying I'm giving them latex and toxin, what I expect to have happen is I expect the change in the body size of the caterpillar, and it might be bigger, it might be smaller, but I expect there to be a change in the body size. Okay, so here I'm testing latex and toxin, and what I expect to have happen is a change in the caterpillar body size. Okay, so here's the actual data that we are going to be working with, or we are going to be graphing here. So the data was already collected. So then what we're going to do is we are going to put this on the graph. Now this first graph I want to point out says that this is graphing latex levels. Do you guys see that? Latex levels. And this one is graphing the toxin. So one is doing latex, okay, like that, and one is doing the toxin, okay? So they're different. And after that, I am going to get all the latex levels. And on this, on my data table, I have the latex levels, I have the toxin levels, and then I have the size of the caterpillar. Well, for right now, if I'm going to do the latex graph, I need the latex and the size of the caterpillar. So what I'm going to do is actually take a little strip of paper, just so my eyes are not confused by the middle data set, and I'm going to cover up the middle data set. You don't have to do that, but visually it just helps me to stay on track so that I'm in the right space. So for the first thing, I'm going to say, what is the latex level? The latex level in this sample is 1.5. So I'm going to go over to 1.5, and the size of that caterpillar is 5.4. So I'm going to go over 1.5 and up to 5.4, which is just over, it's between 5 is between 4 and 6 and a little bit more than that. And so I'm going to put a dot. Then the next one is going to be 0.4 and 7.7. So I'm going to go over to 0.4, which is just before 0.5. And I'm going to go up to 7.7, which is about right here. And I'm going to put a dot. Then I'm going to go over to 3.5. So 3.5. And I'm going to go up to 3.4. So 3.5 to 3.4 over here. Okay. Then I'm going to do 0.6 and 9.1. So 0.6 and then all the way up to 9.1. And I'm going to put a dot. I'm going to go to 1.6 and over to 7. So 1.6 and up to 7. And I'm going to do 1.3 and 6.1. So 1.3. So I'm going to go over to about 1.3 and up to about 6.1 and put a dot. Then I'm going to go 3.0 to 7.5. So 3.0 to 7.5 would be about right there. And I want you to go and create that graph all the way down. Now, you're not going to connect the lines, but if I could right now, if I had to stop now, I would say, hey, this line, if I had to put this same strip of paper about across the line, it would be trending kind of like downwards right now. And if that is the case and it continues like that, then you could say that the latex was like, the more latex, the smaller the body size. So it was actually affecting the mass of the caterpillars. Okay, now we're going to move over. You will have to graph all of those. I'm just going to do some of them. But then we're going to graph the next ones. I'm going to get a new colored pencil, and we're going to look at toxins now. So this says toxin along the bottom and the size of the caterpillar. So I'm going to go same thing, 1.4 over 1.4 and up to 5.4. And then 2.1 and 7.7. And 4.9 and 3.4. 4.9 and 3.4. And 4.0 and 9.1. And then I am going to continue to graph that. And then you're going to see, like, is this line one that's going down? Or is the body size actually going up with more toxins? Or is it kind of scattered all over the place where toxins don't even matter to the caterpillars? Okay. So you need to graph all of those points to see that information. Okay. Then wrapping up to finish this. You are going to make a claim that answers the scientific question. And remember, the question was that we asked in the beginning is, are caterpillars affected by the different defenses? And you're going to say yes or no. So you're going to say caterpillars are affected by the defenses, or caterpillars are not affected by the plant's defenses. Or you can say some plant defenses affect the caterpillars and some don't. Okay. And then what evidence do you use to write your claim? And you can reference parts of either the data table. Now, this data table is pretty complicated, so I wouldn't necessarily reference that, but I would probably reference my graph. And I would say something like on the latex one, if it does continue downward, I would say like if I just had to go off of this much data, I would say something like the caterpillars that had very little latex were also some of the biggest ones. And the caterpillars that got a lot of latex were very small, and I would reference it that way. Okay. And it'll be different for the toxins. And then you're going to write, explain your reasoning and why the evidence supports your claim, and connect back to what you've learned about this relationship. Okay, so what did we learn in here? We did learn from the data, I would say that, if we're just looking at the latex, I would say something like the latex is affecting the body size of the caterpillars. And that makes sense because the caterpillars in the reading have to work really hard to cut the veins to drain out the latex before they can even feed. That takes a lot of time and energy. They also get a mouthful of latex, which is like a sticky white glue, when all they want to eat is the leaf. And all of those things are affecting and taking their energy instead of giving them time and space to grow. So the leaves that don't have very much latex, they're able to grow more because they're able to spend more of their time and energy eating the leaves, which is their actual food, not the latex. Okay. And then this last one, did your data support your hypothesis? And then say why, yes or no. So you can't just write yes or no. You need to explain and give me like an explanation to that. So you could say, I was partially right because, this did affect the caterpillars. A certain thing did affect it, but this other one didn't affect it at all. Or you could say, hey, I was right in both cases. The toxin and the latex both affected the size of the caterpillars and they didn't do well. Or you can say, hey, I found out that the size of the caterpillars was actually positively affected by the more toxins and the more latex it has. So give a final shout out going back to your hypothesis about if your hypothesis was right or wrong, or partially right or wrong, and then say why. So that's how you are going to complete this assignment, how milkweed plants defend against monarch butterflies.